Thank you everyone for joining us today on another exciting Dagster deep dive. Today we're going to be talking about how Lee Littlejohn here over at US Foods built a data platform using Dagster at the core of it to empower his team to ship better data products and get the most out of their platform. Next slide, please. Yeah, so we'll do some introductions. Lee will discuss his platform principles, the pain points, the tool selection, the platform foundation, his Dagster implementation, and then we'll open it up to Q&A. And me, I'm Alex Noonan. I'm a developer advocate here at Dagster Labs. I'm also a data engineer, and I have worked primarily in the small and medium-sized business space, building data platforms and using Dagster, of course. Lee, you want to take it away?
Yeah, let's do it. Hey, I'm here today to show you how we built our data platform using Dagster and a few consistent principles and design decisions. My name is Lee Littlejohn, and I work for US Foods, one of the largest food service distributors in the country. We're number like 119, I believe, on the Fortune 500, billions in annual revenue, some 30,000 employees, pretty big company. Before I started as a software engineer, I was a restaurant chef and US Foods customer. Running a kitchen and building a data platform might not seem terribly connected, but I found that they're actually quite similar. In a busy kitchen, everything's about coordination, efficiency, quality under pressure, constantly juggling multiple stations, managing inventory, ensuring consistent quality while maintaining rapid service. Sound familiar? If you've ever worked in or on a data platform, it's all about coordinating different components, managing resources, and ensuring that everything runs smoothly and reliably. So I noticed a lot of these parallels when I was first getting started, and quite frankly, feeling a little overwhelmed. We had all these disparate scripts, Jenkins jobs, isolated tools, and data products that weren't exactly talking to each other. It reminded me of starting in a new kitchen, I guess any new job really, but much more complex than a kitchen. In both situations, I sought to create systems that were efficient, maintainable, and easy to understand. The principles that helped me in both worlds were surprisingly similar as well, minimizing unnecessary actions, reusing components intelligently, and reducing cognitive load by establishing clear sources of truth, logical connections between systems, and clear organization. Today, we're going to walk through how we use these principles to transform our chaotic data ecosystem into a clean, centralized platform using Poetry, the AWS CDK, the Cloud Development Kit, GitHub Actions, Dagster, of course, and Snowflake. So by the end, hopefully you'll see how we've created not only an efficient system, but an empowering system where our data practitioners can focus on delivering business value rather than fighting with infrastructure, which is oh so common. So let's talk about the core principles that guided our platform redesign. What's efficiency's nemesis? Disorganization. Disorganization quickly overwhelms our primitive caveman brains, and we have to fight that cognitive overload with clear, consistent patterns. So this is the picture I actually took one night of a garde manger station. When I was running the kitchen, I was pretty upset at the state of Garmo that night. This is not a photo of efficiency and clarity. I hope that this doesn't remind you of your data stack, although I fear that it might. So what are we doing here? We're trying to reduce cognitive load. In a kitchen, a cook shouldn't have to worry about whether or not there are like clean plates available and everything. You should just offload that responsibility and trust that it's handled in order to perform at a high level. So similarly, data scientists shouldn't have to become experts in 24 AWS services just to run models and run experiments. Let people focus on what they're actually good at. So we need to keep things maintainable. We shouldn't build systems that are painful to update or modify or fix when they do eventually break. Modularity is another key principle, right? In kitchens, you prepare base components that can be used in multiple dishes, stocks, sauces, etc. In our data platform, we want reusable components that can be combined in different ways to serve various needs, interfacing cleanly with each other. We've established a single source of truth for each domain. So like in a kitchen, there should be one recipe book or maybe two, one for pastry, kind of throw them a bone, not 10 different versions floating around. In our platform, we need one definitive place for each type of information or configuration. We also want to establish parallel patterns that are consistent and predictable. If you know how one part of the system works, you should be able to intuitively understand how the other parts work too. So we try to proactively design things so they wind up where people might think they should be. This is horribly subjective, but the idea is that if you feel like you need a spoon and you instinctively reach for a spoon, it should already be there. If you have to go looking for it, it's probably not where it should be. Of course, we want to minimize action while maximizing output. Nature seeks to transition from higher energy states to lower ones, and so do we. And finally, transparency is key. Everyone should be able to see what's happening in the system. Gatekeeping knowledge, any part of the system, is antithetical to progress. Sunlight is the best disinfectant and whatnot. And this picture is a photo of my station at a tiny little spot on the north side here in Chicago, where we had to get creative and be super efficient with our space. And knolling here, that's the art of arranging things at right angles and staying very organized. Always be knolling. Everything on my desk currently is also knolled, nice right angles, very clean. I always know where everything is. I'm broken in that way. It's actually quite helpful in this domain. Okay, big picture. Here's the big idea. What you're seeing here is how all of our tools connect. We start with Poetry for dependency management, which feeds into our containerization strategy. The AWS CDK uses those pieces to define the infrastructure, and GitHub Actions manages the deployments themselves. So Dagster runs on this to orchestrate all of our data workflows, which ultimately interact with our Snowflake data warehouse. What I really like about this is that each component has a clear, well-defined purpose, and they all work together through consistent patterns. So as we go through each piece, keep these sort of parallel patterns in mind to see how everything fits together. Dagster's code locations are perfect for this. So before we dive into the solutions, let's talk about some of the challenges we were facing, challenges that I'm sure many of you are familiar with. First, we had silos, different teams using different tools, different processes, basically speaking different languages. Getting cross-functional alignment was tricky. Always hard to convince people that their Kung Fu is not actually the strongest Kung Fu, because there is no strongest Kung Fu, just different Kung Fu for different circumstances. We also had friction around resource utilization and access. People had inconsistent roles and permissions, inconsistent access patterns. As always with silos, visibility is an issue, right? We had redundant work happening with duplicate code and data sets because teams simply didn't know what already existed. And governance, let's just say that our environmental and database boundaries were flexible, and they really shouldn't be. So I don't need to go on and on because I'm sure this is painfully familiar to many of you, but it's important to acknowledge where we were to appreciate how far we've really come.
Now, Lee, what did cognitive overload feel like for your team and like the wider organization?
I mean, very, very tedious. Working on big, fragile systems kind of weighs on you, but tedious and fragile, right? Like ticky-tacky, hazy. You know what you're looking at in the moment, but everything on the periphery is a little hazy. You're not exactly sure how these things are all interacting with each other. And so there's a lack of confidence when working in a fragile system like that. To give you a sense of our starting point, it felt a little messy. Granted, hindsight is 2020 and everything, and it's easy to look back and see flaws, but that's what growth is. I'm sure in another year or two, everything we have now will look pretty different as well. And at the time, it all felt like the right thing to do. But as a new employee, it was certainly challenging to get a solid handle on how it all worked. Jenkins' job was running random scripts on inconsistent schedules, fragmented DAGs and elation that nobody fully understood, ad hoc scripts living on individual laptops, infrastructure more soup than architecture. That's the diagram here, infrastructure soup from an ancient Dagster blog, actually. It's basically a stock photo, not mine. And one of my personal pet peeves, database tables with names like this, customer underscore data underscore dev underscore Smith. If you're over indexing your table name to include deployment environment and developer name, and someone isn't yelling at you about it, they're abdicating their duties. All of this led to development bottlenecks and fragile systems. One change could break something completely unrelated, and troubleshooting was a nightmare. So how do we choose our tools? Anybody who practices a craft loves their toolkit, and engineers are no different. So we selected Dagster as an orchestrator for several compelling reasons. Its asset-based orchestration focuses on the data product itself that you're creating, not just the process. This aligns perfectly with our goal of creating clear, visible data products. It's got a great UI and monitoring capabilities that give us an unprecedented visibility into what's happening with our pipelines. It has extensive and extendable integrations that we can connect to virtually any system we need to. Dagster's strong typing helps catch errors early and make our code much more robust. It uses a familiar Python interface with dependency injection, which lowers the barrier of entry for users. Basically, anything you can do in Python, you can do in Dagster. It's extremely flexible, and that flexibility is very powerful. And perhaps most importantly, Dagster gives us visibility, capital letters, intentional here. We can see what's running, what's failed, what depends on what, and so much more. Another huge advantage here is the parity between local and cloud development. You run the exact same code, same packages on your laptop that will run in production, which makes development and testing a lot smoother. But Dagster is just one piece of the toolkit, right? We're using lots of other tools to create a cohesive platform, as you can see in this little wishy-washy diagram. Poetry manages our dependencies everywhere, but it's at the top here because it happens on our local machines, and it's the single source of truth, as we're about to get into here. GitHub for version control, GitHub Actions for CI/CD, Docker, obviously, sometimes DBT, sometimes SageMaker. All of that lives on AWS, where the CDK defines infrastructure as code. Dagster does the orchestration, and again, Snowflake stores the data. So what I'm really proud of about this stack is that each component maps directly to the next in a consistent pattern. Poetry defines the dependencies that go into the containers, which are deployed by the CDK and GitHub, which runs Dagster, which interacts with Snowflake as a clean, logical flow. And we're going to track how code locations map to all of these various pieces.
Was vendor lock-in a concern for you and your team when you were making these tool selections?
But not really. We've gone with mostly open source tooling, except for the things that we didn't have control over, right? We were within the AWS world, so within here you can do basically whatever you want, and we were within Snowflake, so within there you can do basically whatever you want after we got everything provisioned, which was a relatively long conversation. Okay, so let's go ahead and dig in. Starting at the beginning here, we've got poetry and the PyProject.toml file. That's the foundation of our entire organizational structure. It defines all the dependencies and crucially our team structure through dependency groups. Each team gets its own dependency group, which enables selective modular deployment. And this means we can install only the package a particular service needs rather than installing everything everywhere. So this ensures consistency across environments, local, dev, staging, prod. They all use the same dependencies defined in the same way. So gone is the sprawl of multiple requirements.txt files with different versions and configurations and nested folders. There's one source of truth for packages here. We also use a tool called the Poet for streamlined task execution. This gives us consistent commands for common operations like provisioning, testing, linting, machine setup. It prevents needing a make file and having a separate file for where some of these things are defined since they're so analogous to local development and the single source of truth. We can have it all in the PyProject.toml. For those not familiar with Poetry, it's a dependency management and packaging tool for Python that's a lot more powerful than pip. It handles virtual environments, dependency resolution, and package publishing in a much more elegant way. The basic setup is straightforward. You define your project metadata and dependencies, and Poetry handles the rest. But what's really powerful here is the dependency groups. It keeps our deployments lean and focused. This team-based structure flows through our entire platform. It's the first application of the one-to-one modular mapping and parallel design patterns that we're going to harp on over and over again here. It kicks off the idea that I'm not actively thinking about an arbitrary number of code locations in teams. I think about one general pattern, and that applies to all code locations in teams. So we've got our virtual environment now, and now we need to containerize it.
Have you guys thought of using UV as a poetry replacement?
Yeah, for sure. It's the new hotness. We've definitely thought about it. UV has an analogous grouping mechanism for maintaining groups, and the Poet is also compatible with UV due to the PyProject.toml file, so it's definitely on the roadmap to make that change. Our containerization strategy builds directly into the foundation, or on the foundation rather, laid by Poetry. We use a multi-stage Docker file that serves as another single source of truth. This strategic one-to-one modular mapping continues here, right? The Poetry dependency groups map directly to container stages. Each team's code location gets its own final build stage in the Docker file. So the Saute team and the Garmo team, these are obviously fake working groups for the purposes of this demonstration, but each defined here as a dependency group in Poetry, they each get their own container stage. So the Saute team's container only includes the dependencies that they need, and the same for Garmo. Get exactly what they need and very little else. This approach produces slim images that contain only what's needed for each specific service, right? And we're careful not to invalidate the cache unnecessarily, which you'll see here soon a little bit with the CI/CD process and how we deploy individual containers separately from each other, and that optimizes those build and deployment times. We use layer caching on ECR with BuildX to further speed up the builds. Seems like a minor detail, but when you're waiting for deployments, every minute counts, right? Now that we have our containers, how are we going to deploy them? With the AWS Cloud Development Kit, of course. AWS CDK allows us to define our cloud resources using actual code rather than YAML or JSON. I think object-oriented programming feels better than YAML. You could use YAML, but I think this is way more fun. CDK gives us another single source of truth for our architecture, right? We have a clear defined structure for how our resources are organized and related. We use a single upstream infrastructure stack that defines shared components like infrastructure buckets, load balancers, and other resources that multiple teams might need. And our CDK stacks run our code on ECS Fargate. I read once a long time ago in a blog, the author called it chill Kubernetes, which I really like. It gives us many of the benefits of container orchestration without the operational complexity. Continuing our one-to-one mapping pattern here, we have one stack per team or code location. Each stack defines the ECS Fargate tasks and services needed for that team's workloads. And it continues this clear connection. The team name flows through from Poetry to the CDK, maintaining that consistent identifier throughout the system. Here you can see a Saute stack and most of its components. Easy to look upstream and see which image, build stage, dependency group, and code location it corresponds to. This organization makes it easy to understand which resources belong to which team and how they relate to each other. If a new team joins, adding infrastructure is very straightforward. It follows the exact same pattern as everyone else. So let's talk about how we automate the deployments themselves. GitHub Actions, long live the king. We use GitHub Actions to automate the building and deployment of our containers and infrastructure with a label-based workflow that makes it easy to target specific components for deployment. So, for example, adding a deploy dev saute label or a deploy dev garmo label to a pull request will trigger the deployment of just that team's stack and not the others, so teams can deploy independently to their various Fargate services and all operate in the same development Dagster instance. The workflows are team agnostic, meaning they're not hard-coded to specific teams. They use the same team name extracted from the label itself to target the correct upstream constructs. So the deployment pipeline follows a pretty consistent pattern here. We build a container for the specific team by targeting the specific build stage for that team, which uses the Poetry dependency group for that team. We apply environment-specific configurations for dev, staging, or prod, and then deploy the stack. So again, here, the team name flows through the entire CI/CD process, maintaining that consistent identifier from Poetry to GitHub to AWS. So this gives us a lot of flexibility while maintaining consistency. Teams can deploy their changes independently, but they all follow the same process and patterns, which reduces deployment failures and confusion. So let's take a look at how we organize the actual code to support this modular approach. What does it look like when we're coding in an IDE? One of the most important aspects of our platform is how we organize the code, right? Separated by working group. Here you can see the Saute and Garmo directories. Our code location strategy is simple, one code location per team. The directory structure mirrors the team organization, making it easy to find what you're looking for. And we generate asset key prefixes with this structure as well. Team, project, asset. That's how all of our assets are labeled and prefixed within Dagster itself. Each code location runs in its own dedicated Fargate task, which provides isolated resources and dependencies. This means teams can have their very own concurrency limits and configurations without affecting other teams. Within these code locations, we organize our core Dagster concepts, assets, ops, jobs within team and project boundaries. So here we can have clear ownership and responsibility. We enforce absolute imports only, which helps avoid the quote-unquote import circus, where it can be hard to tell where the code is coming from. This way we can interrogate and execute Dagster constructs by importing them directly into the warm embrace of a Jupyter notebook. And the imports look the same no matter where you're looking at it within the repo. So if the Saute team needs something or needs to create a new data pipeline, they know exactly where to put the code and how it will be deployed. Copy over project template, change some names, import everything all the way up to the team's shared init.py file, add it to the definitions object once at the beginning, and then it's over. And you can add as many assets as you want in code, and you never have to import them again once you do the initial setup here. Then they don't need to worry about interfering with other teams' work or navigating a complex shared code base. This structure also makes it easy to understand data dependencies, right? If one team's assets depend on another team's assets, those relationships are explicit and visible. Let's talk about how we configure things across environments. For each code location, we've got triplicate deployments, development, staging, and prod. Each environment has its own set of configuration options specific to that team. So different teams might need different resources. For example, one team might need Kafka integration, another needs MS Teams for notifications. Our configuration approach accommodates these differences while maintaining consistency, thanks to the Dagster resource construct. Dagster uses dependency injection to manage these resources. It means we define environment-specific resources and configurations once and then inject them into functions where they're needed. This approach ensures that the same code can run in different environments with appropriate configurations without requiring changes to the code itself. So developers don't have to worry about the underlying infrastructure or environment or resource details. Switching things up based on environment happens at the top level, not at the code level. So you only code it once and it just works everywhere. For example, a data pipeline that reads from a database will automatically connect to the development database in the development environment and the production database in production without code changes. This resource configuration, the dependency injection framework in Dagster, this is really where the magic happens. Your assets, your Python functions, they get to use these connectors and resources with a single mental entry point. You add Snowflake resource to an asset, and you can trust that resource is pointing to the correct database and schema. You don't have to think about it. So specifically with the Snowflake resource, we use team and project tags to pre-configure the engine, the connection engine. So we automatically set the Snowflake database and schema based on the team name and project name. Again, this means users don't have to specify these details for every asset or in every Python file. The system already knows where the data should go based on their team affiliation. So it keeps things lean, fast, and lowers that forever pesky cognitive overload. We also use job tags to set ECS resource allocation. This means teams can specify compute resources they need for different jobs, again, without really having to worry about the infrastructure details. You need more RAM? All right, go ahead. You can try that by editing the tag right in the launchpad. And if it works, change the default and the job definition with a real PR. This approach reinforces some big ideas, right? Like consistent patterns and reduced cognitive load. Teams can focus on their data and analytics work without getting bogged down with the infrastructure details. So, Snowflake. Got to talk about how we organize the data in Snowflake, which is the final destination for most of the processing. So we've got one database per team per environment, so really 3 databases per team. This creates the same direct mapping from code locations to databases, maintaining that one-to-one modular mapping principle. We use the same consistent naming conventions that makes it easy to understand what data belongs to what team and which environment. Database, team, schema, project, right? And it matches the same thing with the asset keys and the key prefixes. It enables efficient access control. So we rely on Snowflake's hierarchical RBAC, role-based access control, to mirror our team structure with environment-specific permissions. This ensures that people have access to the data that they need while maintaining appropriate security boundaries. So one powerful feature we really enjoy and leverage a lot is the zero copy cloning. So this lets us create copies of the data without duplicating the actual underlying storage, which is great for testing and development. And we've automated the environmental refresh using Dagster jobs as well. So for example, we can refresh any dev table with a copy of production data with a single click, making dev with realistic data much easier, which is often necessary when you're doing data science on rapidly evolving situations. So this sort of completes the flow from code to data storage. The team name that started in Poetry flows all the way through to the Snowflake database names, creating a consistent, predictable pattern throughout the whole system. Integrations. So Dagster's got great integrations, and our platform doesn't exist in isolation. It's got to integrate with various tools and services across the data lifecycle, right? So Dagster's integrations are clutch here. Outside of AWS, of course, and Snowflake, obviously, and the Dagster AWS library, which we use extensively. Our big 2 integrations here are DBT and SageMaker. So we have a multi-project architecture for DBT. For those users who find it helpful, we're not trying to enforce DBT use, but if you want to do it, you can. So DBT projects can go anywhere within the system, within any project, allowing for really flexible organization. And we built translators that apply the key prefixes and the metadata, the same that our other assets do, to match up with that same design schema with the team project asset or database schema asset. It's all the same situation. This enables powerful patterns like using Dagster partitions to drive incremental DBT models, which then generate optimized Snowflake merge statements. For heavy ML and GPU use, we have SageMaker integration that enables team-specific workflows. We built a custom SageMaker pipes client. Shout out to Pat. Makes it easy to orchestrate ML pipelines on SageMaker within the Dagster ecosystem. If it can be accessed via Python, it can be integrated into the platform, right? So it gives us just tremendous flexibility to incorporate new tools and services as needed. Back to that OG diagram, right? It should all make a little bit more sense now. So let's see how all these pieces fit together, end-to-end workflow. So let's walk through what happens when we make a change and deploy it through the system. So let's say we want to add a new station to the platform, right? Let's call it the grill. So first we would add a new dependency group called grill in our PyProject TOML file. We would create a new directory for that team's code following our code location strategy. We would add a new CDK stack for the team, defining their ECS Fargate resources and everything it needs to actually run out in the wild. Then when we push these changes, make a PR, and add the deploy dev grill label, then GitHub Actions kicks off a workflow. The workflow builds a container for the grill team and pushes it to the grill team's ECR repo, and then deploys a new CDK stack for the team. And this creates all those necessary Fargate resources. Then Dagster starts running with a new code location, and the team's assets materialize into their very own Snowflake database. So the team name grill flows through the entire system from Poetry to Snowflake. Again, that same consistent identifier at every stage. So you always know where things are and you don't have to think about it or get lost. Lots of benefits for doing things this way. Troubleshooting and maintenance are simplified because of consistent patterns. Teams can self-service many of their own needs without waiting for platform team intervention, so quickly implementing new features and changes. The system's standardized yet flexible enough to accommodate different team needs, and there's clear ownership and responsibility for each component. Self-serve data access for analysts and data scientists is absolutely crucial when running lean. And while we're not really diving into this bit today, it's worth noting that we've integrated tools like GitHub Copilot and Confluence for business documentation, where the page content itself is version controlled within the repo and pushed automatically upon changes. Adoption of a new platform, that's never automatic. It requires a cultural shift, upskilling, and some hand holding, but hand holding's not pejorative in this sense. It's actually good, right? It fosters collaboration and a shared understanding between data practitioners and platform owners. What else does this thing do for us? Standardized development practices and improved code quality, better governance through consistent patterns and clear boundaries. We've got faster development cycles due to significantly reduced friction. And then, of course, reduced cognitive load at all levels by tightly scoping individual components with shared patterns and interfaces. I think we've covered a whole lot in a relatively short amount of time here. One last insight would be that reducing cognitive load isn't really just about making things simpler. It's about making the right things simple so you can have people focus their energy where it really matters the most. And I think that's it. I think that's all I got. To conclude, I'll just say that our key themes, we're trying to reduce cognitive load, trying to keep things maintainable, trying to build in efficiency with modular design. We want to have single sources of truth per domain, the recipe book analogy there. We want to share parallel patterns. As always, we're trying to minimize action and win the game with the fewest moves. And we want the whole thing to be as transparent as possible.
Oh, Lee, that was a fantastic presentation. I think it really resonated with me, just the notion that as you're thinking about like how you build out your data platform and how like various people interact with it, setting it up in a way where they can focus on what's important and not get bogged down in details that don't matter. And I think that's just fantastic. But before we kick off our Q&A, I want to mention if you aren't a member of our beloved Slack community, please join. Links right there. And also follow us on socials so you don't miss any Dagster updates. And also, I don't know if everyone here has heard, but we recently released components into community preview, which is our new YAML-based abstraction to build faster with Dagster. So you should check that out. The link to the docs is below. And then you should also register for the webinar with our founder and CTO, Nick Schrock, where he'll explain the vision of components and how to get started with it. Yeah, so let's get into the Q&A. So the first question from Nicholas is, why would you create a layered Uber Docker image where each code location is its own layer when you can simply deploy each code location independently?
Super subjective choice, right? That was just because I felt like doing it that way. I wanted everything to be in one place so I could know exactly where it was. I didn't want to have n number Docker files littered throughout each code location and then have to reference those things, or have n number Docker files in an infrastructure folder where it's dockerfile.saute, dockerfile.garmo, where they all come from a different base image. With the layer caching in ECR, you don't necessarily have to have a base image that's built separately to pull from because those layers are already cached in ECR. So we're just skipping that process of having a base image and then pulling from it for individual other images with separate Docker files. Super subjective choice. You can definitely do it in 100 different ways. This was just really how I felt it would be most manageable by a super lean team.
Awesome. And then Joe asked, I've sometimes needed to use a prod database while testing dev code. You mentioned environment settings aren't set in the code, sounding like they're set in the config. Can you still add workarounds for these edge cases like this?
In the sense that like you need to talk to prod while doing dev work. For us, we've managed to do that from within the data warehousing side, right? So the hierarchical role-based access for Snowflake means that prod has the least privilege, staging has more privilege, and then dev has the most privilege, right? So all of our dev roles can access read-only staging and prod those higher environments. So that way, if we need to use that prod data, we can read that prod data from any of the lower environments. If we need to clone that data down from prod to dev in order to have real prod data without messing with the code at all, we can do that with Snowflake with zero copy cloning. But you can also, if you have to, I don't recommend it, but if you have to, you could put just some sort of flag in a config object where the default is always read from the environment that you are currently in. If there's like a development flag and you flip that flag to true in the launchpad and then have a little conditional statement to swap out the database in your query, you can do that. It defeats the purpose of not having to think about where your database engine is pointing while you're doing development work, but that doesn't always work out so cleanly, like I've been talking about. Like you frequently have to do weird little workarounds to make it all happen correctly. Config object versus zero copy cloning. And I think there's a lot of different ways to skin that cat.
Awesome. And then Jan asked, how do you parallelize like the highest volume data pipelines?
We do a lot of that by using the dynamic output for op-based jobs and not asset-based jobs. The best resource here would be the Dagster documentation on all of this, but you can do branching dynamic DAGs within individual jobs where you have a branching out pattern where one op will yield these dynamic branches with mapping keys, and then each one of those branches can take a subset of the data and process them individually. We've got things on Fargate, so we're using the multi-process executor. So if we've got 32 gigs of RAM and 8 virtual CPUs, by default, it would make sense for us to break our data set up into 8 parallel streams, yield 8 dynamic outputs, and then run with it that way. You could also loop through in batches and then only have 8 processes running at a time, and then it'll cascade down through smaller batches, but still only running 8 branches of this dynamic output DAG at one time. So that's how we do a lot of it currently. But we're looking into other methodologies to try and make that a little simpler on the user. Data frame libraries that are not pandas, for example, that can actually do that without fighting it. Polars, good stuff. Check it out. But yeah, I would say read the docs. It's, frequently, my answers to people's questions are, did you read the documentation? Because you should. Yeah, check out the dynamic output stuff.
And then Nicholas had a follow-up question to the like big Docker image with the layered code locations. Did you run your code locations within virtual environments? Separated?
Like locally, because obviously in the Docker image, we're only getting every image clearly has its own virtual environment. That unique virtual environment per image is very much the dependencies from the poetry dependency group, right, which are isolated. So locally, local machines run all dependencies. We're not Dockerizing local development because it's just overhead that we don't need to have. The poetry and the dependency groups and using like pyen for Python versions, all that good stuff lets us not have to put these things into containers. And so local dev use, we install all packages for all dependency groups, and then you're just set and ready to go. So the way that Poetry works with those dependency groups, they all have to resolve, but you don't have to install all of them. Locally, we're doing the regular Dagster dev command, but we'll target code locations to spin up to make sure that we're not wasting a ton of time spinning up all of the code locations. And then we just install all of the packages in a single giant virtual environment locally. And then again, as the Docker containers are built, we subset that virtual environment as needed.
Sweet. And then what aspects of testing did you incorporate into your platform?
The great testing question with data pipelines, huh? We've got tests for most of our like base components, anything that's like a utility function you can test really easily. Testing the actual pipelines is a lot harder, especially with some of the security that goes around accessing the actual data, right? So GitHub Actions runners we don't have GitHub Actions runners with a dedicated IP, so we can't have that whitelisted to talk to a lot of the real data sources that we're using. So we have to mock out a bunch of that stuff, which can be tricky, but that's what you got to do. Then again, there's the other side of testing, which is like post testing versus pre testing, and that would just be asset checks. So
Mhm.
using asset checks liberally within the system, making sure that you can validate incoming data per asset and validate outgoing data per asset, and then making sure that all that looks appropriate in the development environment before any sort of PRs are merged. And then having those asset checks, if something does fail in prod, you get a failed run in the asset check. If you write it correctly and you write it verbosely, it will tell you exactly what happened and why.
Fantastic. Yeah, it's always great to plug testing and asset checks. With that in mind, we recently released a new course on Dagster University for testing in Dagster. If any of you in the audience are curious about that, you should check it out. But on to the next question from Chetan. What's your job scheduling strategy? Do you like statically schedule them or do you use a sort of dynamic approach?
Definitely depends on the use case, right? So there's lots of schedules that are just crons, basically. with the build schedule from partitioned job function. I believe that's the name of the utility function that handles a lot of that work for us. And then some of the others work on sensors that have to ping some sort of external system or check a state in some other place to pick up and launch another job. We have a lot of jobs that link to each other with run status sensors. So frequently we'll have a longer process that consists of multiple jobs where one job starts with a schedule and a partition, and then that partition feeds through to the other jobs through the concept of a run status sensor. So the sensor waits for the upstream job to succeed. And if it does succeed, it'll take that context, take that partition, and inject it into the next job and kick off a run with that one. And then they daisy chain on down.
Amazing. And then Sam had a question, like, assuming the starting point of your project is the old Dagster image of the like data mess with all the different cadences and tools, what did you find was the most challenging part of moving from the messy design to your current design of the clean modular setup?
Gosh, I don't know. It's hard to answer. The hardest part is definitely actually moving working projects from one thing to another, right? Picking up that code and untangling it. I had a coworker describe some of that type of work as bushwhacking through SQL. And like that's it. Like you just got to put the work in and get it done. And the whole thing's hard. Yeah, that's a real difficult question to answer. It's hard making that migration any way you slice it.
Ron actually has a kind of related question. Did you face any conflicts with the US Foods data team's like existing culture? And did you have to do any process changes outside of the data department?
Certainly some conflicts internally. People don't like change, right? So you have to show them that things are actually, you will save time if you put a little bit of the work in up front to upskill and learn how this new thing works. The old thing will feel very antiquated very quickly if you move on to the new platform. So it's just a matter of getting some people to do that as examples, and then it should be pretty clear. The benefits are pretty obvious. But yeah, I mean, there are always going to be people who are resistant to change. I'm one of them.
Hmm.
Yeah, that was definitely true. What was the second part of the question?
Did you have to change any processes like external to your team?
Yeah, if you're sharing a data product, you have to manage how you interface with those other teams, right? And so a lot of in the sort of old system, pretty willy-nilly, drop a table here, tell somebody that's where it is, and they read it. So in our sort of new world, our final data product should ideally be a table or a view in Snowflake, and then you share exclusively that table or view with whatever Snowflake role that person already has. So not really a big change, just codifying how it should happen because it's basically the same thing, right? You're still just sharing a Snowflake thing for the most part.
Yeah. And then when you like initially proposed this migration, did you do like a proof of concept project?
Yeah, I think this is my like third or fourth open source Dagster deployment. Yeah. Had a couple of goes at it before something looked clean enough to get the green light.
Yeah, that's a testament to your tenacity and quality and trying to build the best platform. So,
Gotta have nice things. I gotta have nice things.
and then Mikado over here has a question is how long did it take for you and your team to migrate to this new setup? And what's the size of the team that you're working with?
What constitutes full migration would be my counter argument there. There are some things that are still kicking out there in the old way that we haven't gotten to yet, but we're mostly there. Those are very few and far between. It took a long time, right? It took, I don't know, maybe a year to get the bulk of it pushed over because existing work, that work doesn't stop. Like it has to keep going and new things are happening too. So who's got the time to do these migrations? Nobody, basically. Yeah, it took some time to get it done. And our team, our little MLOps team within the analytics and data science division, I think we got 7 people right now, 6 or 7 engineers. Yeah, I don't know why it's so hard for me to count, but 6 or 7. That's how big our actual team is.
Yeah, considering the size of your organization and working with a team that lean, it's pretty impressive the fact that you guys like went from like design proof of concept to serving production data within that time frame. 'Cause I think all of us have been on migration projects that that took like a lot longer, required a lot more people and a lot more resources. So don't discount yourself, Lee. You guys did a great job.
Thank you. Thank you. And I've heard anecdotal stories from other people that some teams at some other organizations, they look at the cost benefit analysis of doing that migration, and the migration itself is just too much, and it's worth burning the money on the existing thing because the migration is just too much of a pain and they're just not willing to do it. So we were lucky that US Foods was willing to do it and that it was a priority to have a proper data platform. And yeah, another thing I'm really proud of about this is that it's been extremely successful in terms of deployments, right? Like I think we had brief downtime for a migration last week, so this number probably isn't super accurate anymore, but it's something like 99.996% platform uptime. We've almost never had anything go down out of almost 750 production deployments, like full production deployments. We have had less than 8 failures, and none of those resulted in actual downtime. I think that's pretty good. And 4 of those were me and one of my coworkers playing a little fast and loose and trying to get around our own branch protections. And so we shot ourselves in the feet with those. And the 2 of the remaining ones were expected due to CDK inconsistencies and how cloud formation is just a pain to work with in general. And so really there were only like 2 proper prod deployment failures that we didn't understand and didn't think were going to happen. So I'm really proud of that. We've had well over millions of jobs execute successfully and 99% job success rate. Very few failures due to having these systems in place and enforcing some of these standards. So like really proud of the success of the platform.
Yeah, I bet you guys are able to sleep through the night, just like a baby.
Except for the fact that I have a baby.